Spanning across an endless expanse of shimmering stars and swirling cosmic energies, my journey begins with a deep dive into the boundless chronicle of our galaxy's formation. I find myself immersed in the thrilling narrative of cosmic evolution, where every nebula and every pulsar holds a story rich with scientific marvel and historical significance. My narrative unveils the raw forces of nature that sculpted the heavens, intertwining gravitational ballet with the elegant orchestration of nuclear fusion. Within this infinite canvas, I recount the epochs that laid the foundation for existence, weaving together intricate threads of astrophysics, cosmology, and the legacy of ancient wisdom. In the earliest moments, which, despite the passage of billions of years, continue to echo through the vast corridors of space, the universe transitioned from a quiescent state into a theater of energetic upheaval. I illustrate the cosmic birth of galaxies, explaining how delicate perturbations in the primordial plasma eventually condensed into clusters of blazing stars, each group displaying its unique architecture and design. With a friendly yet precise tone, I guide my audience through the intricacies of cosmic chronology, highlighting the interplay between dark matter, baryonic matter, and cosmic inflation. This voyage is not merely a recount of events, but rather a passionate exploration of the scientific phenomena that shape our very existence. My narrative reveals how the fundamental constants of physics underpin the formation of galaxies, and how these processes resonate with myths and legends from civilizations that came before. Thus, I invite you to journey with me, to traverse the majestic and turbulent epochs of galactic history, and to discover the profound connections between the cosmos and our collective human pursuit of knowledge and understanding. In this scientific odyssey, every observation and data point emerges as a beacon illuminating the intricate tapestry of universal evolution, indeed. In the primordial cauldron of the early universe, I delve into the scientific framework that explains how the first galaxies formed. The process begins with minuscule quantum fluctuations that, propelled by the rapid expansion during cosmic inflation, created regions of slightly higher density. These density contrasts, though barely perceptible, set the stage for gravitational clumping. Over millions of years, gravity exerted its inexorable pull, drawing together hydrogen, helium, and traces of heavier elements. In these regions, the fabric of space-time bent under the immense gravitational forces, triggering a cascade of stellar birth and galactic assembly. As structural elements coalesced, swirling accretion disks formed around nascent stars, and the processes of angular momentum conservation ensured that spiral arms took shape in disk galaxies. I describe how turbulent gas clouds cooled and fragmented, drawing attention to the complex interplay between energy dissipation and gravitational instability. This fine balance between pressure forces and gravity is also evident in detailed simulations run by astrophysicists, which demonstrate that even minor variations in initial conditions can lead to vastly different galactic structures. Moreover, I explore the role of dark matter halos that envelop emerging galaxies, serving as unseen scaffolding around which ordinary matter accumulates. Through precise mathematical modeling and simulation data, researchers have confirmed that dark matter is essential for explaining the rotation curves of galaxies and the distribution of luminous matter. The dynamics of these halos, often simulated using N-body software, provide profound insights into the nonlinear evolution of cosmic structures. I then transition to discussing the impact of supernova explosions and stellar winds that, while destructive, actually contribute to the chemical enrichment of the interstellar medium. Such explosions redistribute heavy elements, enabling subsequent generations of stars to form with increasingly diverse chemical compositions. This narrative, rich with equations and astrophysical models, illustrates a delicate symphony of cosmic elements, a dance governed by the immutable laws of physics and the relentless progression of time. Furthermore, I examine simulation results from high-resolution cosmological models that capture the evolution of gas dynamics and dark matter interactions over billions of years. These simulations reveal shock waves, turbulent cascades, and the intricate process of radiative cooling that further refines the structure of forming galaxies. The data indicates that multi-scale interactions, from subparsec turbulence to megaparsec gravitational clustering, are intertwined in a complex feedback loop. Advanced computational algorithms, running on supercomputers, validate the delicate equilibrium between heating by supernova feedback and cooling from molecular gas processes. This equilibrium is essential for understanding star formation rates and the overall evolution of galactic ecosystems. In these models, the predicted variations in chemical abundances are consistent with spectral observations, confirming theory and empirical evidence walk hand in hand indeed. In the vast expanse of cosmic history, the emergence of ancient civilizations is interwoven with the birth and evolution of galaxies. I recount how early spacefaring societies, armed with advanced astronomical instruments and computational models, charted the heavens with precision. These civilizations, drawing upon a deep understanding of quantum mechanics and stellar physics, established observatories that rival modern instruments in their accuracy and scope. Their culture was deeply rooted in the recognition that the universe itself was an intricate tapestry of cause and effect, where cosmic events such as gamma-ray bursts, pulsar timings, and gravitational lensing were not merely phenomena, but signs imbued with profound meaning. I highlight the scholarly endeavors of these early astronomers, who meticulously recorded celestial events and used mathematical models to predict planetary alignments and supernova occurrences. Their data, often inscribed in stone or transmitted through primitive computing devices, serves as a testament to their rigorous pursuits. Detailed star maps emerged from these studies, correlating stellar evolution with metaphysical myths and ritualistic practices. The interplay between the objective rigor of science and the subjective interpretation of legend is a recurring theme in this narrative, offering a fascinating glimpse into how knowledge can be both empirically robust and culturally transformative. Advanced civilizations also harnessed early forms of computational astrophysics, running simulations that modeled the dynamics of interstellar matter and energy distributions. Their encoded calculations, preserved in crystalline data storage, predicted the behavior of complex systems such as spiral arm formation and intergalactic collisions. I reflect on the innovative methods used to overcome the limitations of their era, including analog computing techniques and early iterative algorithms that laid the groundwork for modern numerical simulations. In these narratives, technology and intuition merged seamlessly, offering solutions to cosmic puzzles that continue to challenge experts today. Furthermore, evidence from archaeological excavations on ancient planetary systems reveals that these societies left behind artifacts containing encoded scientific observations and theoretical treatises. These relics, meticulously studied by modern astroarchaeologists, provide insight into sophisticated concepts such as chaotic dynamics, fractal systems in nebulae, and the probabilistic nature of quantum events. It is evident that even in their formative stages, these civilizations possessed an adept capacity for both abstract theorization and practical experimentation, a duality that remains central to our current understanding of astrophysical phenomena. Modern analytical techniques such as spectral analysis and time-domain photometry reveal striking parallels between ancient records and current astrophysical data. Researchers compare light measurements encoded in ancient texts with modern redshift calculations, finding remarkable consistency. Detailed analyses of ancient star catalogs using contemporary statistical methods confirm that early observations accurately reflect periodic celestial phenomena and variable star behavior. As experts refine computational models that bridge historical records with current dynamics, the legacy of these early civilizations exemplifies how deep scientific inquiry transcends epochs. Their methods continue to inspire innovations in data modeling and simulation, unifying millennia of astronomical research into a coherent narrative of cosmic evolution. In a transformative era, driven by technological breakthroughs and an ever-growing ambition to conquer the cosmos, I traverse the epoch of space exploration that once seemed purely the stuff of science fiction. My narrative unfolds amid starships powered by fusion reactors, gravitic drives manipulating space-time, and quantum communication systems that link distant worlds with instantaneous clarity. It is an era where scientific rigor and adventurous spirit converge, creating a tapestry of exploration that is as scientifically sound as it is imaginatively daring. I delve into the precise mechanics of interstellar propulsion, explaining in technical detail how ion drives, plasma thrusters, and antimatter reactions are integrated into the design of spacecraft navigating the gravitational wells of multiple star systems. Advanced simulations reveal the intricate balancing act required to optimize fuel efficiency while managing relativistic effects, ensuring that explorers can travel vast distances over timescales that, while enormous to human perception, are minute on a cosmic scale. In this journey, I recount the extraordinary missions launched into uncharted territories, where crews, composed of expert navigators and scientists, encounter phenomena that defy conventional physics, such as time dilation near neutron stars and the unpredictable disturbances of cosmic ray storms. Every mission is depicted with numerical precision, highlighting metrics such as acceleration rates measured in meters per second squared and observed shifts in spectral lines caused by intense gravitational fields. Moreover, I reflect on the collaborative efforts between interstellar alliances, where knowledge is shared and technological advancements are pooled to overcome intergalactic challenges. In this era, exploration becomes a unifying endeavor that bridges cultures and species, uniting disparate groups with a common goal: to chart the unknown and understand the fundamental laws governing our universe. The technical details, interwoven with the allure of adventure and the possibility of encountering alien phenomena, create a narrative that is both exhilarating and intellectually stimulating. To further illustrate the scientific rigor behind these explorative endeavors, I detail the in-depth design calculations behind improved warp field theories and subspace metrics. Advanced research continually refines our understanding of cosmic radiation, matter-antimatter asymmetry, and the influence of black hole dynamics on interstellar travel. Each discovery builds a bridge between theory and practice, forging a robust platform for future space quests and innovative exploration. Through precise calculations and peer-reviewed experiments, humanity pushes the limits of technology, venturing boldly into the unknown realms of the universe indeed. In the sprawling framework of galactic history, conflict emerges as a catalyst for revolutionary change and scientific progress. I chronicle an epoch where ancient empires and emergent alliances clashed across the interstellar void, their battles meticulously orchestrated with both brute force and refined strategy. In this narrative, academia and militaristic ingenuity interplay as detailed simulations and strategic models reveal the mechanics behind political upheavals and battlefield dynamics that span entire star systems. I describe the evolution of conflict in precise terms, presenting data on kinetic energies released in supernova-caliber confrontations and the gravitational perturbations resulting from massive fleet maneuvers near binary star systems. Technical analyses highlight how relativistic physics and advanced propulsion systems were harnessed to induce tactical advantages, where precise timings and orbital mechanics dictated engagement outcomes. Researchers utilized high-fidelity simulations to predict the results of these confrontations, integrating data from laser interferometry, dark matter distribution maps, and quantum sensor arrays. This era of galactic conflict is not only marked by physical battles, but also by a profound ideological awakening. Revolutionary ideas surged as affected populations embraced emergent technologies and novel governance structures that resonated with the principles of decentralization and collective intelligence. I narrate, with supportive numerical data and among other metrics, how disruptive innovations in communication, energy harnessing, and computational theory galvanize citizen groups and reform-minded leaders. There is a clear, measurable shift from traditional hierarchical rule to more distributed and modular social systems, as verified by extensive simulations and statistical analyses conducted by leading theoreticians. Over time, as old orders crumbled under the weight of technological advancement and public demand for accountability, a new era emerged, one defined by scientific collaboration and open-source paradigms. In this reconstructed socio-political landscape, every revolution is underpinned by meticulous research, rigorous debate, and the pioneering spirit of innovation. With each calculated maneuver, the trajectory of intergalactic conflict edged closer to a transformational awakening, where war gave way to a renaissance of knowledge and a redefinition of power in the cosmos. Meticulous records of battle statistics, energy transfer rates, and simulation outputs support these accounts. High-resolution data from telescopes and gravitational wave detectors further validate the dynamic shifts and revolutionary trends noted during this tumultuous period, offering profound insights into the internet of power, technology, and ideology in the galactic arena. I shift my narrative toward the horizon of future possibilities, where the legacy of galactic endeavors inspires a renewed vision of hope and progress. I explore emerging theoretical frameworks such as multiverse cosmology and quantum gravity that promise to revolutionize our understanding of the cosmos. Drawing on detailed data from both cosmic microwave background measurements and deep sky surveys, I illustrate how these new paradigms challenge traditional models and open avenues for further discovery. This segment emphasizes the transition from the era of conflict to one marked by collaboration and shared scientific ambition. I describe how interdisciplinary research in astrophysics, particle physics, and computational science is leading to innovations in energy, transportation, and communication across vast interstellar distances. With a relaxed tone that is both informative and inviting, my story reflects on how past achievements meld with future aspirations in a seamless continuum of exploration. Moreover, I contextualize the resurgence of visionary projects, including the establishment of new space agencies and public-private partnerships that aim to harness the collective potential of humanity and extraterrestrial knowledge. These initiatives are underpinned by rigorous scientific inquiry and robust data analyses, fostering a culture where technology and tradition converge. In my narrative, every technical breakthrough and every theoretical insight paves the way for transformative progress, ensuring that the spirit of discovery endures. Looking ahead, I emphasize the importance of integrating cutting-edge research with long-held scientific principles. Future missions, powered by unprecedented computational power and refined experimental techniques, will unlock deeper layers of the universe. The continuous pursuit of knowledge promises an era of enlightenment where precision measurement and innovative theory coalesce to reveal the secrets of existence. I conclude my narrative with reflective musings on the vast continuum of cosmic history. In this final meditation, I consider the interplay between deep scientific inquiry and the timeless allure of the stars. The exploration of galactic evolution, from its violent beginnings to its hopeful future, mirrors the journey of knowledge itself. A journey defined by both rigorous analysis and boundless imagination. I observe how each numerical datum, each simulated orbit, and each recorded anomaly contributes to a grand narrative that transcends time and space. My reflections draw upon a wealth of empirical evidence and advanced theoretical models, underscoring how even the most intricate cosmic processes are unraveled through persistent investigation and intellectual curiosity. This concluding chapter reaffirms that every discovery, every calculated risk, and every theoretical breakthrough propels us closer to understanding not only the universe, but also our place within it. As I leave the audience with these final thoughts, I invite them to ponder the delicate balance between precision and wonder, a balance that continues to inspire future generations of explorers and scientists alike. In the endless expanse of reality, our quest for understanding remains the most profound adventure of all, indeed, forever.